Here we have the Swords of Truth. A very nice laser engraved piece. We have 8 different swords. You'll notice each sword has 6 two-digit numbers. Each number is surrounded by either a square or a circle. This is a very neat mental math magic sort of trick, if you will, but it does take a little bit of time to learn and master to be impressive and also to really sell it, to be honest. Of course, it does come with full instructions for those that want to give it as a gift. For real math lovers, they won't have any trouble with it, but it does have some level of sophistication to learn. So here's what we do when a customer comes up and I want to give a demo. I will show them the swords. I'll say, just pick any sword, pick any number on the sword. Let's say, for example, you picked the number 17. And I'll often point to the last number just for illustration. And I will tell the visitor, I'll say, look, I won't know which number you pick, but what you're going to do is read the shapes from left to right that surround these numbers. However, when you get to your number, you are going to fib and say the opposite shape. So for example, if you were looking at the number 17 and I wouldn't know this, you would say circle, circle, square, 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 square. Because again, you have them fib on the one that they're looking at and thinking about. And I'll actually explain that to them just like I am now. And then after they know that, I will have them turn away or so I can't see, and they'll pick one. And they're going to read out shapes. Now, for example, let's say that they say this: square, square, circle, square, circle, circle. Okay? I'm actually encoding the number 64. We'll do a couple so you can learn this if you haven't already. Square, square, circle, square, circle, circle. Okay, so 64 is a number that they're thinking about. Now, what did they say? I've got a post-it note here. We've got the first 3 digits, or the first 3 shapes, if you will, and then the last 3 shapes. And you're going to find that the first 3 shapes are going to encode the tens digit of our answer, and the last 3 shapes are going to encode the ones digit. So they said square, square, circle. This is a binary code. Squares equal ones. Circles equal zeros. Practically speaking, you can ignore the circles or the zeros, but you have to pay attention to the squares or the ones. So when they say square, square, circle, they're really saying in binary 110. Now, what does 110 mean in binary? I'm not going to take the time to fully explain this, but binary is a base 2 system. We are used to normally using a base 10. We've got normally 0 through 9. It's our ones digit, and once you get bigger than 9, you have to bump over to the tens digit. When you get bigger than 9 here, you've got 99. You go up to 100, etc. We're very familiar with that base 10. Once you have 10, you go up to the next digit placeholder. For base 2, once you get bigger than 1, you've got to go over to the next one. So all you really need to memorize or remember is that this first one is representing 4s, this one is representing 2s, and this one is representing 1s. Same way with the last 3, representing 4s, 2s, and 1s. So when they say square, square, circle, they're really saying 110. They're saying we have 1 value of 4 plus 1 value of 2 plus 0 value of 1. If it's a 0 or a circle, just ignore it. So they've just told us we have a 4 and a 2. So I know the tens digit is 6. Then when they say square, circle, and again they're fibbing here, circle, square, circle, circle. In other words, 1, 0, 0. So they're telling me I have 1 value of 4 and I don't have any value on the 2's or the 1's digit place. So I now have a 4 here, 64. Let's try 1 or 2 more just for practice here. All right. And when you get good, you won't need to write this out. You can just think about it. Let's do 26, okay? Write it up here so we don't forget. So they would say to us, circle, square, circle, 0, 1, 0. That's 0 4s, 1, 2, 0, 1. So I have a value of 2, we already know. Then we're doing 26. They would fib here, square, square, circle. In other words, 1, 1, 0. I have a value of 4 plus a value of 2 plus no value of 1. 4 plus 2 is 6. So in my mind, it's 26. Now, without writing it down, if they say let's do 27, okay? So, circle, square, circle. I've got a value on the second one, which is a value of 2. And then we say square, square, square. So a value of 4 plus value of 2 plus value of 1 is 7. The value is 27. A very impressive trick. Does take a little bit of learning and practice. You can make a cheat sheet if you like, and whatever works for you though. Have fun with it. Swords of Truth.